We'll continue with Lecture 2 and discuss data visualization. Data visualization has historically been used in science and engineering because it's a very powerful analytic tool as well as communication tool. The design visualization of the Roman Marcus Vitruvius are still available today. James of St. George was an ingeniator, or engineer in our modern terms, and mason, or mason. Leonardo was a big user of data visualization, and of course Gaspard Monge of France. So the demands of the Industrial Revolution increased the complexity of our designs, and in France, Gaspard Monge developed what's known as the descriptive geometry. It was a state military secret in France for several decades. Visual analysis became an integral part of ensuring correct and optimal function of systems that were developed. And it was used also as a communication mechanism to others and to create historical records for monitoring change. So today we are presented with two problems regarding data visualization. How do we make sense of the data, and how do we communicate the results of any analysis on the data? Of course, the computers revolutionized data visualization. Computer graphics is now a principal analytical tool. Visualization activates the spatial reasoning ability, and that's an assist to verbal descriptions of problems. The real nexus of information visualization in the social sciences is to reveal social memes. It helps us look at sentiment and influence. Sentiment is a nominal category and can be made more granular than positive or negative. It can show hate, anger, affection, and affiliation. And visualization has also traditionally been integrated into analysis by the social sciences. John Snow's cholera outbreak and Charles Booth's cholera outbreak analyses were some of the first and some of the great success stories in visualization in the social sciences. Of course, today, big successes in environmental science. Here's an illustration of John Snow's deduction that a cholera epidemic was caused by a bad water pump. The horizontal lines indicate locations of deaths, and he plotted the center, the geographic center of it, and it turned out to be that pump that's circled in red here. So visualization enhances our understanding. We use the perceptual system as well as our cognitive system, and so we engage a different part of the brain at the same time. So more memory is available to aid in our understanding. The perceptual system also operates in parallel, while our cognitive system is something that operates serially. This combination enables recognition of related data without the need to recall the parts and piece them together. So visually organizing data enhances the recognition of patterns, trends, and relative values. So visualizations help us see hidden relationships, help us identify trends. And here's a saying by Confucius that gives us a sense for the importance of visualization in reasoning. So we organize a visual space the same way we organize and categorize data. We have nominal data, ordinal data, and quantitative data, and we use that in our GIS designations for data as well, because nominal and ordinal will permit certain GIS operations. Quantitative will permit almost all of the operations. The graphics leverage our perceptual sense-making, and they do this in multiple ways. They can assist in comparisons by varying the length, shape, or orientation of a presentation. Animation can represent change over time, and we'll be looking at that kind of animation in a GIS in one of our lab exercises. Color can be used for grouping and to show distinctions. And of course, GIS has the ability for us to designate various color schemes for representing and presenting our information. Pre-attentive processing is an important aspect of our cognitive ability. Some visual content can be processed without the need for our attention, and that's pre-attentive processing. And that can be used to advantage by visualization. When the display correctly casts the data so that the goal information is apparent, then we can use this pre-attentive processing. To do this, however, requires rules for setting up discriminators so that we can properly set up this information. And we want to avoid combinations of properties that lead to complications. Basically, something is pre-attentive if we can categorize it and make sense of it within 250 milliseconds. In other words, the time it takes for a single glance. So one of the rules we might use as a discriminator is color as a single discriminator. A difference in color for the target information allows the observer to quickly and accurately detect if the goal is present or not and where it's present. And we can see that here in this slide figure. Likewise, we can use a shape selection as a rule for discrimination of our target from the background information. So a difference in shape is easily detectable as well. The observer can quickly and accurately determine if the goal information is present or not. And we see that here with the circle among all the squares. Pre-attention with union of features is more difficult. In fact, we may not even get pre-attention in that particular case. With two or more features used to characterize the target, we cannot determine at a glance if the target is present. We must look at the set sequentially through each one and find out which one is different. And of course, here we see in the right square, the red circle is the one that's different. But we're mixing different colors with different shapes here, and it's not something that we can process pre-attentively. It requires us to use our cognitive brain and go through and look at each thing analytically. Emergent features are another characteristic that we can use to help us quickly grasp what's going on with a particular analysis. Grouping elements has an impact on our perception, and grouping can result in emergent features. And these are shapes that are more discernible in the group than in isolation. The contours that distinguish them may become more obvious when they're organized into groups in contrast to other organizations. And symmetry and closure are some of these characteristics that can be more apparent, resulting in superior presentation of the target. So here we see the use of symmetry and closure differences. The targets have a different closure and a different symmetry than the distractors or the non-target information. So a target group here that is contiguous is displaying emergent features by its contrast with non-target elements. Unique features of shape and closure like this are pre-attentive. Here we have non-pre-attentive group features. So here the distractor and the target have the same symmetry and closure, they just have a different orientation. And so the lack of uniqueness in shape or closure makes the target not as obvious, but we can see that in fact we do have a different orientation right here amongst that group, which is our target group. But it's not as obvious, and clearly something that's not pre-attentive. It requires us to go through and spend a great deal of time thinking through it. So our vision does not work like a camera, and photography is a relatively poor metaphor for sight. Instead, our vision is similar to an ongoing construction project. So to see how photography is not really a good metaphor, and that our vision is really similar to an ongoing construction project, let's look at a couple of slides. We'll let you analyze them. So take a look at this, and there's two photographs side by side, and see what's different between them. What you'll realize shortly is that our mind fills in gaps that we actually aren't in these particular photographs, and that's because our mind does more than just record images like a photograph. It's processing them so that we add in expectations along with other things into our visualization interpretation. So as you can see, the photograph on the left side has an engine, whereas the one on the right does not. Okay, and again, look for what's different in these. Of course, they look almost identical. And again, it's the whole idea that our minds interpret things. It's not just they're analyzing a photograph. There's interpretation that's going on as well, and our mind fills in the gaps and makes a complete whole for us. So they are different. Although at first glance you might think they're the same, if you study them very, very carefully, you'll notice everything's the same except the color of the man's trousers on the left. And finally, we've got these set of side-by-side photographs, identical in almost every way. But again, our mind, if we looked at them, would say, yeah, these two photographs are identical. It adds in and glosses over the differences. It provides an interpretation that, yeah, we look at a number of features and our mind comes to the conclusion it's the same. But in fact, there is a difference. The glare on the windshield of this Mercedes-Benz is different in the two photographs. So that concludes our lecture on visualization. It's a very powerful tool for analysis as well as communication. We have to set up good discriminator rules so that we highlight the target information that we're interested in and do it in such a manner that it's very obvious what the target is. And we also have to understand how we think and how we go about doing visualization so that we don't fall into a trap of having images that in fact our mind adds in interpretations to. Good evening.